Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I'm going to continue with your same module, that is a new module that we have started in the last class, that is your object-oriented programming with C++, that is your object-oriented programming. In the last class we have started this module. We have talked about this module, that is why we are approaching this module or why we have started this module, what are the advantages of object oriented, and why I have started this module after the theory subject. And there are so many discussions, that is a basic discussion about this module. And then we have started with chapter number 1. There are so many topics, there are so many chapters, like 14 to 15 chapters we have studied, like what are the basics, who is the author, what are the total chapters in this book, and what are the contents of the chapters. Then we started with the chapter number 1. What's the name of first chapter? That is the principles of object oriented programming. Principles means ground levels. Ground level means the rules of the object oriented programming. The first one says, or the first topic that we have studied is the software crisis, and these are the various topics in this chapter. We have covered with till this one, encapsulation. Now I'm going to continue with these few topics in the today's class. So first of all, we have started with the software crisis. That is, what is software crisis? That is whenever there is a development of the software, but till now we are, or many users or many organizations are far beyond the software, or the lacking of the software. That is a software crisis. That means there is more requirement of the software, there is no requirement, there is advancement that appear to be created conditions of the crisis within the industry. That is the condition also says that there will be a condition of the crisis that occurs in the situation of the crisis. The following issues need to be addressed to face this crisis. That is, what are the various crises, or what are the various issues that need to be addressed, that need to be handled to face the crisis. That is, how to design the system with open interface, how to read the reusability. We have studied these so many questions, that is or that makes an impact, or that makes an advancement to the software crisis. Many software products are either not finished or not good, or else are delivered with major problems. And this is a diagram that shows a histogram that is used with various projects that illustrate that the software industry is used with developing the projects. Then these are the various levels of the project, that is 1, 2, 3, 4. And the first one says that is paid for but not received. That is, we have paid for but we have not received till now. Then delivered but not used. Then abandoned or rework. Then used after change, or used as delivered. So these are the various changes, these are the various levels that is used. That is the state of the US defense projects. That is the level, or the state, or what is the condition of the US defense projects. Then we have studied that if there is a change in the requirement, that is a major problem, because if the requirement of the user has changed, so everything is changed, because we have built the product, we have built the software as per the user requirement. But if everything is or if the user requirement is changed, so that also makes the impact on the studies, or that also make the impact on the data formats. These studies and the other reports on software implementation suggest that software products should be evaluated carefully for their quality before they are delivered. So whatever the report that is given also software development also notify that they are delivered carefully and they are implemented carefully. Some of the quality issues that must be considered for critical evaluation are, so what are the various quality issues that must be considered for various criteria, or for various critical evaluation? What are the various issues that is used? So first one is correctness. So these are the various issues that must be considered for the critical evaluation, that must be taken care of for the critical evaluation. First is correctness, maintainability. Second, reusability. That is, the software that is built is correct, that is maintainable, that is we can simply or we can easily maintain the products. Then reusability, then openness, then portability, then security, then integrity, then user friendliness. So these are the eight topics that must be considered whenever we evaluate the software. So these are the critical evaluation criteria, and this is the how there will be a breakdown of the cost in various requirements. So 42% lies for the change in the user requirement. Then software evaluation, that is what is software evolution and how the software will be evolved, or how software will develop from the part to part from over the last decades or over the last 5 decades. That is, what is the growth of the software. This is, as complexity increases, architecture dominates the basic material. So these are the various modules, these are the various topics, these are the various layers of the computer software. That is how software builds, or what is the software evaluation. That is, what are the various growth levels, what are the various levels of the or layers of the computer software. So first one is machine language. That is, we have started with, or there is a first language, or there is a first software that is developed, that is known as the machine language. In this, only bits are used, that is either 0 or 1. Then after machine language, there is a language that is known as the assembly language. In this, the mnemonics are used. Mnemonics is a keyword that is used to write the program. For example, if I want to add two numbers, we can use ADD add, then 2 plus 3. That is, ADD is known as mnemonics, and the spelling is sorry, I'm so sorry, MNEMONICS. That is mnemonics. Then next is procedure oriented, in which the main program is divided into various functions. Then object oriented programming, in which the main program is divided into various objects and the classes. Right. So these are the various 4 layers of the object oriented, or 4 layers of the computer software. Then with the advancement of the languages such as C, structured programming become popular. Then we have talked about the procedure oriented or procedure oriented programming. That is, what is procedure oriented programming and how it is used. That is how it is used. That is how, what is the meaning of the this one. That is the object oriented or the procedure oriented programming. In procedure oriented approach, the problem is viewed as a sequence of things that is to be done, such as reading, calculating and printing. A number of functions are written to accomplish this task. That is, a number of functions are used to accomplish the task. The primary focus is on functions. So what is the primary focus? That is on functions. And the technique of hierarchical decomposition have been used to specify the task to be completed for solving the problem. So in procedure oriented, the main function is divided, or the main program is divided into various functions. And that functions are maybe further divided into various other functions. So there is no hard and fast rule that various functions are used or no. Then procedure oriented programming basically consists of writing of instructions for the computer to follow. Organize these instructions, that is known as functions. The same we have studied in this. There is also global data, and this is the most important that we have studied, the various features of object oriented programming. These are various features, and the most of the important feature is last one feature, that is it employs. That is, a procedure oriented programming uses top-down approach in program design. That is, it uses the top-down approach in the program design. That is your procedure oriented programming features. Then next is your object oriented programming paradigm. That is, what is the object oriented programming language. So the main objective or the main motivating factor in the invent of object oriented approach is to remove some of the flaws that is encountered in the procedure. That is, there are loopholes in the procedure oriented, like data move freely from one part to another, so there will be hacking of data, or there will be a chances of hacking of data. So what are the various tracking features that is available in object oriented programming? What are the various features? First feature is it emphasis on the data rather than the procedure. In object oriented, everything focused on the procedure, everything focused on the function. But in object oriented, emphasis is on data rather than the procedure. Then programs are divided into what are known as objects. That is, main program, the main function is divided into various objects. Then data structure are designed such as they characterize the objects. Then next is data is hidden. That is, it cannot be hacked by anyone else. That is, data is hidden and cannot be accessed by external functions. Then objects may communicate with each other through functions. That is, objects, different parts of the program may communicate with each other through the functions. Then New data and functions can be easily added whenever necessary. So new data and the new member function can be easily added, can be easily add on whenever there is a need for the adding of the functions. Then it follows, that is object oriented programming follows bottom up approach, that is it follows from bottom to top. The word main is available at the bottom approach, in the bottom, that is it follows the bottom up approach. Then basic concepts of object oriented programming, that is what are the basic concepts that is used in the object oriented programming. So it is necessary to understand some of the concepts that is used extensively in object oriented programming. So what are the basic concepts? First one is objects, that is what is the object, then classes, then data abstraction and encapsulation, then inheritance, then polymorphism, then dynamic binding, and then method passing. And we have covered in the last class till till encapsulation. So we have studied about the objects. What is the object, or what are the objects? That are simply runtime entity. So any runtime entity in object-oriented system, or any runtime entity that is your basic runtime entity, that is known as the object-oriented, or that is known as the object. So whenever there is any runtime entity on which the user commands, that is known as the objects. They may represent a person, they may represent a place, they may represent a bank or table of data. That is, the objects may be a bank, may be a place, may be a table of data, or any item that the program has to handle. That is the objects also handle user-defined data type. That is, there will be a usage of the user-defined data types we have used in the objects. And one important thing is that object also takes the space in the memory. And objects, this is the object, that is a student, this is a data, that is a name, date of birth, marks. Then functions, what are the functions? Like total, average, display, that is a functions. Now next concept is classes, that is what is a class. So objects are runtime entities that is used in a system, and classes are the combination of the objects. So whenever we combine multiple objects, whenever we combine multiple objects, that is known as the, or that is contained in the classes. The entire set of data and code of an object can be made a user-defined data type with the help of a class. So whenever there is a collection of various objects that is combined into what is known as the class. So class is a user-defined data type in which the data and functions are summed up in various together functions, in various approachable functions. Each object is associated with the data of type class with which they are created. A class is thus a collection of objects of similar type. That is, whenever we collect multiple objects that is of similar type, we collect them within a class, that is a class. So a class is a collection of objects of similar type. For example, mango, apple, orange are the members of the class fruit. Classes are user-defined data types and behaves like the built-in types of programming language. This is the if a fruit has been defined as a class, then the statement this will create a object mango. So this is fruit is a class and mango is an object. Then next is data abstraction and encapsulation. That is, what is data abstraction and what is encapsulation? That is, data abstraction means hiding the details. As the name advises, abstraction, that means abstract anything, abstract the data, that means hiding the details. In simple terms, whenever there will be a hiding of the, whenever there will be not including or not showing of the background details, that is only representing the essential features, and without including the background details or explanation, that is known as the abstraction. So abstraction means that is the act of representing essential features without including the background details or explanations. Classes uses the concept of abstraction that are defined as a list of abstract attributes such as size, weight, and cost. That is, data abstraction means abstract the data. That means hiding the data. That means only including the background, only including the essential features without including the background details or explanation. And then next term is encapsulation. Encapsulation, that means encapsulate means combine various data. So encapsulation means binding. That means in a class, whenever we bind the data as well as the function, that is known as the encapsulation. So the wrapping of the data and functions into a single class, into a single unit, into a class, that is known as the encapsulation. So encapsulation means wrapping of data and functions together. That is known as the encapsulation. Since the classes uses the concept of data abstraction, they are also known as ADT, that is the abstract data type. So since classes are used with the concept of data abstraction, that's why it is known as abstract data type, that is ADT. Then next one is inheritance, that is your next part. Now that is your next basic concept of object-oriented programming, that is your inheritance. So let's start. This is the today's session. We have finished with the yesterday class session. So let's start with the today's session, that is the inheritance. This is a new concept. This is a new concept for you. So inheritance is the process by which objects of one class acquire the properties of objects of another class. In simple terms, it is a process by which objects of one class, suppose there are two objects, one object is for one class, one object is of one class. So it is a process by which objects of one class, that is object of one class, acquire means gather, that means take out the properties of objects of another class. That is, one object take the properties, take the feature of another object of another class. It supports the concept of hierarchical classification. That means if I am a son, my father has some attributes, some features, I gain some features from my, or I acquire some features of my father with the help of the heredity. That means that is known as the heritation. That is in the same way there is an inheritance, that means capturing the details or acquire the properties of objects of another class, that is known as the inheritance. It supports the concept of hierarchical classification. That is, it take out the concept of the hierarchical classification. For example, the bird robin is a part of the class flying bird, which is again a part of class bird. So bird robin is a part of the class flying bird. So bird is an object that is a part of the flying bird, which is again a part of the class bird. The principle behind this sort of division, that is, what is the principle, that is how inheritance is used, is that each derived class shares some common characteristics with the class from which it is derived. That means the main principle or the main condition is that each derived class shares, that is, if there is some derived class, for example there are two classes A and B. B is a derived class, A is a base class. Suppose there is a division or there is a derived class. So main condition is that derived class shares some common attributes, some features with the class from which it is derived. That is, it is not that if the class becomes a derived class, that means it cannot take anything, but it's a mandatory condition, it's a scenario, that is, if the class is derived class, then it take out some properties from the base class. In object-oriented programming, the concept of inheritance provides the idea of reusability. That means the same code or the same object can be reused, same property can be reused. So in object-oriented programming, the concept of inheritance provides the idea of reusability. That is, we can reuse the content, we can reuse the features. This means that we can add additional features to an existing class without modifying it. That is, if the one class has become the derived class, so one class that becomes a derived class take out their features or take out the features from the base class as well as add on the new features. That is, we can add additional features to the derived class along with the already existing features. This is possible by deriving a new class from the existing one. The new class will have the combined features of both the classes. That is, a new class which is developed, which is built, that have a properties, that have a characteristics, that have a combined features of their own class as well as the base class. So that is known as this is known as the inheritance. That means acquiring the properties, or there is a derived class that is built that takes the properties, that takes the features from the base class as well as their own properties. That means derived class contain the properties of their own as well as the properties of the base class. Note that each subclass defines only those features that are unique to it. Without the use of classification, each class would have to explicitly include all of its features. So this is one a class that is your bird, and there are attributes like feather, lay, eggs, right? And there are two derived class that is used. One is flying bird, one is nonifying or non-flying bird. So one is bird, that is your class, that becomes a base class, and there are two derived classes. One derived class is flying bird, another derived class is non-flying bird. So there are two classes that is used, there are two concepts, there are two derived classes. One is flying bird, one is non-flying bird. And non-flying bird and the flying bird have some attributes. They acquire properties, they acquire attributes from the base class, as well as the take out or adding on the new properties, new features, new properties, methods of its own class. So one class is divided into two classes. One is flying bird, one is non-flying bird. Again, flying bird becomes the base class for the new two derived classes. That is, now it's a condition that the flying class is the base class for the two classes, that is robin and swallow. So these are the two kinds of flying birds. One is robin, one is swallow. So this is just an example, but you take from the C++ or the programming point of view. For a flying bird, the bird class becomes base class. For a robin, flying bird becomes base class. For a swallow, flying bird becomes base class. Then there is a non-flying birds. There are various attributes that is used, and non-flying birds are also converted into two parts. One is the penguin, one is the kiwi. One is the penguin, one is the kiwi. Now penguin takes the features, takes the attributes from the non-flying birds. That has also some attributes, that has also new attributes, that are also common attributes, that are or that takes the attributes from the non-flying birds. So this example says then one base class or the one derived class becomes the base class for another derived class. That is, the flying bird is a derived class for the class bird. Now it becomes base class for the two classes, that is a robin and swallows. That is, one derived class becomes the base class for the another derived classes. This is your inheritance. That means acquiring the properties of another base class so that there will be a concept of reusability. The same code, the same function will be reused again and again to improve the efficiencies. Now, next concept is polymorphism. In simple terms, polymorphism means more than one form. So it is another important OP concept, that is your object-oriented concept. Polymorphism means the ability to take more than one form. As I said, that it has the ability, it has the authority to take more than one form. Now let's see how to take more than one form. What is the meaning of form? Then an operation may exhibit different behaviors in different instances. That is, operation defines how to use the different data type or how to use the different behaviors in different instances. The behavior depends upon the type of data that is used in the operation. So what type of or what is the behavior that depends? It depends on the type of data. That is, what type of variables are used or what type of variable that is used in the operation. For example, consider the operation of addition. If I am giving the numeric number, the operation will generate a sum. If I give equals to 2 plus 3, that will give 5, because 2 and 3 are the numeric numbers. If the operands are string, operands means on which the operation is performed. For example, 2 plus 3, 2, 3, that is known as operands. In the same way, if the operands are string, that is in place of numbers, that is 2 or 3, there are operand that is used. If they are strings, then the operation will produce, and then the operation would produce a third string by concatenation. That means if they are number, that gives the output in a numeric form. If they are string, that gives the output in a string form. And then string form addition is known as the concatenation. That is known as or that is given by the concatenation. Now, the process of making an operator to exhibit different behaviors in different instances is known as operation or operator overloading. So, like operands are overloaded, are or take more than one form, in the same way operators are also, or operator can have also more than one form, that is known as operator overloading. So polymorphism means more than one form. For example, addition. If there are two numbers, then the addition will be 2 plus 3, that is 5. If there are two strings, that the addition will be a string, that means that is a concatenation. Figure 1.9 illustrates a single function name can be used to handle different number and different types of argument. That is, let's see what is figure 1.9, that shows how same function will be used for the addition of the numbers and the same function will be used for the addition of the string depending upon the type of argument. Suppose if I given the argument or the operands as a numbers, so it gives the output in a number. If I give the input as a, or if give the operands as a string, then it gives the output in a string. That means concatenation. This is something similar to particular word having different meaning depending on the context. Using a single function name to perform different tasks is known as the function overloading. So whenever I say there will be addition of two numbers, there will be a subtraction of two numbers, there will be addition of three numbers, all this can be done, or all this can be used with different number of argument, that is known as the function overloading. That is, the same function is used, or the same function is used in two concepts but with different argument list. That is, there are two argument list that is used with the two argument list. Now next is your polymorphism. Plays an important role that allows in role in allowing objects that have different internal structure to share the same external interface. That means polymorphism means the same role or the same object having different internal structure, the same having different number of arguments. That means a general class of operations may be accessed in the same manner, even though specific function that is associated with the operation may differ. This is the polymorphism. There is a shape, that is your class that has a function, that is a draw function. This is divided into three parts. The shape class is divided into three parts. One is known as the circle object, one is known as the box object, one is known as the triangle object. That is, these are the three shapes and these are the three functions that is associated with these that are associated with these objects or with these classes. So the function is same. Function name is draw function. Here also the function name is same with no arguments. Here the function name is same but the argument is circle. Here the function name is same but the argument is box. Here the function name is same and the argument is triangle. So arguments are different, that is, the data type and the number of arguments are different, but the name of the function is same. That is draw. So draw is the function that's name is same, but there are different number of argument, different types of argument. For example, circle, for example, box, for example, triangle. So this is known as polymorphism. That means more than one form. That is, at the same time, two operands will add the value. In the same way, two operands can add the numbers. That is known as polymorphism. Now next is, or the next concept is dynamic binding. That is our next concept. This says binding refers to a linking of a procedure call to the code to be executed in response of a call. That means we bind the things, we bind the procedure, we bind the functions. That means binding refers to the linking of a procedure call. So whenever I link any procedure, whenever I link any code to the any function to the code, that is using any function, that is use one function that is to be executed, that is known as the binding. Dynamic binding. There are two types of binding. One is static binding, one is dynamic binding. So dynamic binding, also known as the late binding, means that the code that is associated with the given procedure call is not known until the time of the call at the runtime. That means that the code that is associated with the given procedure call. So whenever there will be a call that is used with the given procedure call that is associated with the given procedure call, is not known until the time of the call at the runtime. It is associated with polymorphism and inheritance. That is, associated means it is used with the polymorphism and inheritance. A function call associated with polymorphic reference depends on the dynamic type of the reference. This is just an example. Now next is message passing. That is how objects may communicate with each other. That is done by the next concept that is known as the message passing. So in simple terms, message passing means passing the message from one object to another object. That may be of single class, that may be of different class. So an object-oriented program consists of set of objects that communicate with each other. The process of programming in an object-oriented language therefore involves the following three steps. What are the three steps? First step is creating classes that define objects and their behavior. So in message passing, the first object or the first function is that creating the classes, or how to create the classes that define objects and their behavior. That is, what is the object and what is their behavior. Then creating the object from the class definitions. That is the next part. In message passing, the object is created from the class definition, and then establishing communication among objects. That is how to establish communication among the object. That is also done by using the message passing. That is how to communicate with each other in a class with the help of an object. Next paragraph says object communicate with one another. Object communicate with each other by sending and receiving information such as the same way as the people are talking, or people pass messages to one another. That is known as the message passing. That is, objects may communicate with each other with different messages, that is passing from one part to, or that is communicating from one part to one message to another part. The concept of message passing makes it easier to talk about building system that directly model or simulate their real-time or real-world counterparts or counter needs. A message for an object is a request for execution of a procedure and therefore invoke a function in the receiving object that generates the desired result. Message passing involves specifying the name of the object. That is, how to specify the name of the object, the name of the function, and the information to be sent. This is the example. There will be an object. This is the information. There will be employee.salary name. There will be this is the message. So this is the object. This is the information. This is the message. Objects have a life cycle. They can be created and destroyed. So every object have a life cycle. They can be created and destroyed. Communication with an object is feasible as long as it alive. Now next is benefits of OOPS. That is, what are the various benefits? That is the next topic. So we are finished with the various concepts of polymorphism. Various concepts means objects, classes, data abstraction, encapsulation, inheritance, message passing, dynamic binding, polymorphism. So we are finished with these basic concepts of object-oriented programming. Now next is benefits of object-oriented programming. That is, what are the various advantages, what are the various benefits of the OOP, that is object-oriented programming. So OOP offers several benefits to both the program designer and the user. That is, object-oriented programming offers various benefits to both the program designer and the user. Object orientation contributes to the solution of many problems with the development and quality of software products. The new technology promises greater programmer productivity, better quality of software, and lesser maintenance costs. So whenever there is a new technology that promises for a greater programmer productivity, that is, there will be high productivity, high programming productivity, better quality of software, and the less maintenance cost. That is, the quality of the software is also good, and there will be a less maintenance cost, that is a lesser maintenance cost. And what are the various advantages of the OOPS? So now let's see what are the various benefits that is provided by the OOPS. First of all, there will be high quality, there will be high development, there will be high usage, there will be a less maintenance cost. That means improving the quality and lowers the maintenance cost. Now next is benefits or the advantages of the OOPS. That is, what are the various advantages of object-oriented programming? The first one is through inheritance. That is, inheritance means that is, with the help of inheritance we can eliminate redundant code and extend the use of existing classes. That is, whenever there will be a usage or whenever there will be a use of inheritance, that is how to use inheritance, or with the usage of inheritance we can eliminate the redundant code. That is, elimination of the redundant code, or with the use of inheritance the same task will be used, that is the extend the use of the existing classes. So this is the one of the major advantage, that reusability with the help of inheritance. Then next point says we can build programs from the standard working modules that communicate with one another. So we can build the programs from the standard working modules, that is, we can build the program for the module that communicate with one another rather than having to start writing the code from scratch. This leads to saving of development time and high productivity. That means saving of the development time and the high productivity, that is also the major advantage of the OOPS. How is that possible? Because objects can start with communicate with each other. So there will be high development and there will be a time saving, there will be a high production, that is high productivity. Then next point says the principle of data hiding. So whenever there will be a data hiding, that helps the programmer to build secure programs. So with the use of data hiding, it is better, or it helps the programmer to build secure programs that cannot be invaded by the code. Then it is possible to have multiple instances of an object to coexist without any interference. Then it is possible to map objects in the problem domain to those in the program. So it is also possible to map the objects. It is also possible to rotate the objects in a various problems. Then it is easy to partition the work in a project based on the objects. Then the data-centered design approach enables us to capture more details of a model in implementation form. Then next is object-oriented systems can be easily upgraded from a small to the large systems. That is, in object-oriented system can be easily modifying from the small system to the large system. Then message passing techniques for communication between objects makes the interface descriptions with external system much simpler. Then next is software complexity can be easily managed. With the use of object-oriented programming, the software complexity, that is what are the various complexions or software complexities, can be easily managed. So whatever the complexion that is faced in the software, that becomes managed. So software complexity can be easily managed. So while it is possible to incorporate all these features in an object-oriented system, their importance depends on the type of the object and the preference of the programmers. There are a number of issues that need to be tackled to reap some of the benefits stated above. Now, this is one of the important lines. Developing a software that is easy to use makes it hard to difficult. That is, whenever we develop any software that is easy to use, that is very easy to cope up, makes it hard to difficult. There are very difficult conditions to develop a software. It is hoped that the object-oriented programming tools would help manage this problem. Next is object-oriented languages. That is, what are object-oriented languages? So this says object-oriented programming is not the right way of any particular language. That is, it is not the right way of any particular language. Like structured programming, OOP concepts can be used using languages such as C and Pascal. Now, this is the topic talked about till now we talked about the basics of object oriented, that is common in every programming language. Now next concept is how to use, or what are the various languages that is dealt or that is combined or that is consult with the object oriented languages. So this says the object-oriented programming languages can also be, or the object-oriented concepts can also be implemented using various languages such as C and the Pascal. However, programming becomes clumsy and may generate confusion when the programs grow large. A language that is specifically designed or that is specially designed to support the OOPs makes it easier to implement them. That is, there are various programs, there are various commands, there are various languages that is specially used for to understand together the concepts of the object-oriented. For example, C++, for example, Pascal, that uses the concept of object-oriented. In the same way, Java also uses the concept of object-oriented programming. The languages that should support several of the OOP concepts to claim that they are subject-oriented or object-oriented. Depending upon the feature they support, they can be classified into two categories. So it depends on the features of the object-oriented programming. They are classified into two categories. One is object-based programming languages, next is object-oriented programming languages. So there are two concepts, one is object-based, one is the object-oriented based or object-oriented programming languages. Now let's see what is object-based programming language, then what is object-oriented programming language. So first is object-based programming language. This is object-based or object-based programming is the style of programming that primarily supports encapsulation and object identity. Primarily means that is that supports on the measure, or that is mainly focus on that majorly supports on the encapsulation and the object identity. So it is a style of programming. What are the main features that is, or what are the main features that is used in the object-based programming? One is data encapsulation, that is wrapping of the data and the functions. Then next is data hiding and access mechanism. Then next is automatic initialization and clear up of the objects. Then next is operator overloading, that is your next concept. Languages that support programming with objects are said to be object-based programming languages. So objects, or the languages that supports the programming with the objects. So any programming or any language that supports the objects classes, that is known as the object-based programming languages. But the main condition is that, the main criteria is that they do not support inheritance and dynamic binding. That is, in object-based programming languages, the concept of inheritance and dynamic binding is not used. But when we talk about the object-oriented programming language that uses the concept of every concept of object-based programming, that is the classes, object, everything, including the inheritance and the dynamic binding. And one of the example is ADA, that is a type of, or that is a typical object-based programming language. So one of the example of the object-based programming language is ADA, that is a typical object-based programming language. Then next is object-oriented programming incorporates all of object-based programming features along with two additional features. So object-oriented is a wider term and object-based is a narrower term. Object-oriented also includes the object-based programming along with the two new features, along with the two additional features, not new features, two additional features, which object-based is not included. What are the two new features, or what are the two additional features? One is inheritance and another is dynamic binding. So these two features, or these two additional features, are a part of the object-oriented also. That is inheritance, that means more than one form, that is reusability. Sorry, not more than one form, but it's a reusability. Then next is dynamic binding, that is at the time of the compilation there will be a binding, that is at the time of compilation the binding, that wrapping of the data and functions into a one place, into a one object, that means dynamic binding. So in simple terms, there are two types of programming languages that supports the object-based programming. One is object-based, one is object-oriented. In object-based everything is same, but two concepts are missing. One is inheritance, one is dynamic binding. and the example of the object based is ADA. But in object oriented includes every feature or every feature of the object based, but also includes the inheritance and the dynamic binding. That means object oriented means object based programming plus inheritance plus dynamic binding, right? And the best example of the object oriented is C++, Smalltalk, Object Pascal, Java. So these are the languages that is used or that uses the concept of the object oriented programming. So what I said is object based features plus inheritance plus dynamic binding is known as the object oriented programming. And these are the various examples like C++, Pascal, Java. So this is a figure that shows what are the various programming languages or what are the various object-oriented programming languages that supports or that has different features or what are the various concepts that is supported by different programming languages like Simula, Smalltalk, Objective-C, C++, ADA, Object Pascal, Turbo Pascal, FL, Java. So these are the various languages and these are the concepts of the or basic concepts of the object-oriented programming. Now, next is applications of object-oriented programming. That is, what are the various applications that is used or what are the various areas in which the object-oriented programming is used. That is your applications of object-oriented programming. Before starting this topic, let's take a break, then move to this topic after the break, that is your applications of object-oriented programming. So first of all, let's take a break, then move to this topic. So come back from the break and now let's start the session again. What we have covered is till now what are the various basic concepts or what are the various difference between the object based programming and the object oriented programming, and what are the types of or what are the benefits of object oriented programming. Now let's see what are the various applications or the application areas in which the OOP, that is object oriented programming, is used. That is the applications of object oriented programming. This says object oriented programming has become one of the programming buzzword today. There appears to be a great deal of excitement and interest among software engineers in using object oriented programming. Applications of object oriented programming are beginning to gain importance in many areas. The most popular application of object oriented programming, that is one of the major application of object oriented programming up to now, has been in the area of user interface design such as Windows. So one of the major application is with the use of object oriented programming, a user interface design is developed, or there will be a designing of the user interface that is known as, or for example, Windows. So Windows has been developed with the use of object oriented programming. Hundreds of Windows or windowing systems has been developed. So 100 of the Windows system have been developed, or 100 of the Windows has been developed with the use of object oriented, with the use of OOP concept, that is their object oriented programming techniques. Real business systems are often much more complex and contain many more objects with the complicated attributes and methods. Object-oriented programming is useful in various type of applications or in real time of applications or in these type of applications because it can simplify a complex problem. The promising areas for applications of object-oriented programming includes. So what are the various areas for applications, or what are the various areas in which the object-oriented programming is used? What are the various promising areas? First is real-time systems. That is, in real-time systems, the programming is also used, or object-oriented programming is also used. Then simulation and modeling. That is, a simulation and the modeling. Then object-oriented databases. That is also application area that is also used for the object-oriented, or the object-oriented programming is also used for building the concept of object-oriented databases. Then next is hypertext, hypermedia, and expertise. So these are the three also these are the three next area that is used. One is the hypertext, one is the hypermedia, and one is the expertext. Then AI and the expert system, that is object-oriented programming, is also used in the expert systems. Then neural network, that is it is also used in the neural network and the parallel programming. Then decision support system and the office automation system, that is object-oriented programming is also used in the decision support system and the office automation system, that is how to automate the office work, or how to support, or how to build a system that is used for supporting, or that is used to or help the managers to take the decisions. That is your decision support system and office automation system. The next one is CIM, CAM and the CAD system. That is the next part. Next point says the richness of the object-oriented environment has enabled the software industry to improve not only the quality but also its productivity. That is, whenever we are using the object-oriented programming, that uses or that improves not only the quality of the software system but also the productivity of the software system. Object-oriented technology is certainly changing the way the software engineer thinks. So these are the various applications that the software engineer thinks, analyze, design and implement. So these are the various application areas in which these are the areas in which the object-oriented programming is used. Now next is summary, that is the crux of the chapter. So we are finished with first chapter of the new module, that is your object-oriented programming. Now next is your summary. That is a summary, that means a few points of this chapter, that is the crux of the chapter, that is the crux point of the chapter. The first point says software technology has evolved through a series of phases through the last 5 decades. That is, software techniques are used, software technologies are used or has evolved, or software has evolved through a series of phases during the last 5 decades. The most popular phase till recently was procedure-oriented programming. That is the most popular phase that is used till recently, till today, was procedure-oriented programming. That is your POP. That is a procedure-oriented programming. Then next point says POP employs or POP uses top-down approach. That is from the starting to the end. That is a top-down approach. That is void main is used at the top end, and then there are member function definition, member function declaration, where a problem is viewed as a sequence of tasks to be performed. A number of functions is written or are written to implement these tasks. That is a POP. That is a procedure-oriented programming. Then POP has two drawbacks, as we studied. First of all, the data is not hidden. That is, the data may move freely from one part to another or around the program, and are therefore vulnerable to changes. Then next is it does not model the real world problem. That it does not support the real world problem. It does not support the real life problem, that is the in which the online problem in which the time is very crucial. Then next point says object-oriented programming was invented to overcome the drawbacks of the POP. That is, object-oriented programming was invented or used, or it is used to overcome the drawbacks of POP, that is your procedure-oriented programming. It employs the bottom-up programming approach. That is, object-oriented follows the bottom-up approach, that is from bottom to top, because void main is declared or void main is used at the bottom of the program. It ties data more closely to the function that operate on it in a data structure than on that is known as the class. This feature is known as data encapsulation. Then next point says in object-oriented programming, a program or problem is considered as a collection of number of entities. That is, whenever we use the object-oriented programming, whenever there is a concept of object-oriented programming, so the problem is considered or the problem is viewed as a collection of number of entities. That is, what is the problem? How the problem is divided? The main problem is divided into various parts, that is known as the objects. And objects are instances, objects are examples of the classes. Then insulation of data from direct access by the program is known as data hiding. We have studied so many concepts, that is, what is data hiding, what is data abstraction, inheritance, polymorphism, dynamic binding, message passing. These are few important concepts. So whenever we give only the essential details, essential methods without giving the background details, that is known as the data hiding. Then data abstraction refers to putting together essential features without including the background details. The inheritance, that is a process by which objects of one class acquires the properties of objects of another class. Then polymorphism, that means more than one form, that is multiple forms, that allows to have more than one function with the same name in a program. It also allows overloading of operators. Then dynamic binding, that means the code that is associated with the given procedure is not known until the time it is used, that is your dynamic binding. Then message passing, that is passing the material, passing the message from the computing area, or passing the message with the objects may communicate from passing the message with each other. Then applications or object-oriented technology have various benefits. And what are the application? It is generally used in the real-time business solutions, and there are a number of languages that support object-oriented programming. For example, C++, Smalltalk, Java. C++ has become the industry standard in language today. And these are the various key terms that is used in this chapter, right? Now these are the various questions that is used. Now comes to the chapter number 2, that is beginning with C++. So till now, first chapter is principles of object-oriented programming. That is, what is the object-oriented programming and what are the various principles that is used by the object-oriented programming. Now next is beginning with C++. That is, what is C++, how to use the C++. That is the beginning with C++. So object-oriented programming have various or there are so many object-oriented programming languages that is used, and some of the examples are C++, Smalltalk, Ada. But now we are focusing on one of the programming language, one of the object-oriented programming language, that is your C++. That is the advanced part of the C that we have already studied. So that is the second chapter, that is your beginning with C++. That is what is C++, how to begin with the C++. And these are the various key concepts that is used in the C++, C with the classes, C++ features, main function, commands, output operator, header file, return statement, variable, namespace, cascading, program structure, client server model, source file creation, compilation and linking. So these are the key concepts of this chapter. Now what is C++? That is the first question, that is the introduction to the C++. Like C, that is a procedure oriented, that is developed by Dennis Ritchie in 1972. In the same way, C++ is an object oriented programming language. It was developed by B. Jarney Stroustrup at the AT&T Bell Laboratory in the Murray Hill. So what is the difference? C is developed by the Dennis Ritchie in year 1972, and the C++ is developed, or C++ was developed by Bill Jarney Stroustrup at AT&T Bell Laboratory in Murray Hill, New Jersey, USA in the early 1980s. Stroustrup, an admirer of Simula 67 and a strong supporter of C, wanted to combine both the languages and create a more powerful language that supports object-oriented programming features and still retain the power and elegance of C. That means every feature of C, every concept of C, every application of C, every feature of C is supported by the C++. The result was C++. That means C++ is there, or therefore C++ is an extension of C. That is, advanced part of C is known as the C++ with some additional features, with some additional benefits, with some additional extensions. Since the clause was a major addition to the original C language, Stroustrup initiated, or initially known as the new language C with the classes. However, in 1983, the name was changed to the C++. So its name was changed in 1983. Now it's become C++. The idea of C++ comes from the C increment operator. That is, the idea of C++ comes from the plus plus operator, that is your C. Thereby suggesting that C++ is an argument, or C++ is an incremented version of C. So what is C++? That is an incremented version of C. During the early 1990s, the languages underwent a number of improvement and the changes. In 1997, the ANSI Standard Committee standardized these changes and added new several features to the language specification. And C++ is the superset of C. That is, what is C++? That is a superset of C. Most of what we already know about C applies to C++ also. Therefore, almost all C programs are also C++ programs. That is, every C program that is used, every C compiler that is used must also execute the C++ programs. However, there are few minor differences between the C program or that will prevent a C program to run under C++ compiler. That is, there are some changes to compile the program, but there are so many changes between the C and the C++. We shall see these differences later and when they are encountered. The most important facilities that C++ add to the C are classes. So these basic concepts are the important facilities that is provided by the C++ in place of the C. So these are the classes, inheritance, function overloading, and operator overloading. So these are the few important facilities that is provided by the C++. One is known as the classes, one is known as the inheritance, one is known as the function overloading, and one is known as the operator overloading. The object-oriented features in C++ allows the programmer to build large programs with clarity, extensibility, and ease of maintenance. That is, what are the object-oriented features, or what are the various features of the object-oriented that allows or that is used, or object-oriented features in C++ allows programmer to build large programs with clarity, extensibility, and ease of maintenance, incorporating the spirit and efficiency of C. The addition of new features has transformed C from a language that currently facilitates top-down structure design to one that provides bottom-up object-oriented design. That is, the addition of new features to the C also makes it a new concept, and it also provides the bottom-up object-oriented design. Now next is applications of C++. That is your next topic. That is, what are the various applications of C++? C++ is a versatile language. Why is it a versatile language? For handling very large programs. It is suitable for virtually any programming task, including development of editors, compiler, databases, communication systems, and any complex real-time or real-life application systems. So C++ is a versatile language for handling the large number of programs, It is suitable for virtually any programming task. That is, it is suitable for the any programming that is used, including whether it may include the development of editors, databases, communication system, and any complex real-life application system. So there are various applications that is virtually used, or that is C++ is virtually used for so many applications like development of editor, compiler, databases, communication system, or any other real-life application system. Since C++ allows us to create hierarchy-related objects, we can build special object-oriented libraries which can be used later by many programmers. That is, C++ allows us to create the hierarchy-related objects. So we can build a library that can be used by many programmers. Next point says, while C++ is able to map the real world problem, that is one of the application area of C++ is that it is able to map the real world problems properly. The C part of C++ gives the language the ability to get close to the machine level details. The next application is C++ programs are easily maintainable and expandable. That is, C++ programs are easily maintainable. We can easily maintain the C++ programs and we can easily expand the C++ programs. When a new features needed to be implemented, when the new features are needed to be used, needed to be implemented, needed to be introduced, it is very easy to add to the existing structure of an object. That is, it is very easy to add, it is very easy to gather, it is very easy to add to the existing structure of an object. It is expected that C++ will replace C. That is, it is also expected that C++ will replace C as a general purpose language in the near future. That the C++ is also used or will be used as a C language with the general purpose language in the near future. This is a simple C++ program. That is your first part, that is your simple C++ program, how to use C++ program. Let us begin with a simple example of C++ program that prints a string on the screen. That is how to use or how to print the string on the screen. That is printing a screen. So there is a hash include iostream.h. That is how to use hash include iostream. That is how to use the or how to build the program. That is how to use the programs. Then that is hash include iostream .h. That is, this is the header file. As we have studied in the C, there is a header file. In the same way, there will be iostream, that is your header file. In the same way, using name space std, that is your namespace. That is your. This is not mandatory either to use or not. But the header file in C, there will be a what happened? Rotating. Hello, hello, hello. Yeah, are you able to hear me? Hello. Hello, hello, hello. Are you able to hear me? Hello. Hello, hello, hello. Are you able to hear me? What happened? Hello. So next is using namespace std. So in C we use stdi.h. In C++ it's iostream.h. Then int main. In C we sometimes use int main, sometimes use void main. So in C++ there will be a int main. That is your first part. That is your int main. Then whatever we want to print, we print in C with the help of the printf. In C++ we print with the help